What if the space-time continuum was torn? Imagine space and time as an invisible fabric that stretches across the universe. This fabric, known as the space-time continuum, connects everything in existence, from the smallest atom to the largest galaxy. But what would happen if this fabric tore? A tear in the space-time continuum sounds like something straight out of a science fiction movie. But let's break down what this scenario could mean and how it might impact our universe in the most engaging way possible. What is the space-time continuum? Before we dive into the idea of it being torn, let's first understand what the space-time continuum is. Space and time, which seem like two separate things in our daily lives, are actually interconnected in the universe. This concept was developed by Albert Einstein in his theory of general relativity. According to Einstein, space and time form a four-dimensional fabric that can bend and stretch in response to the presence of mass and energy. This bending is what we experience as gravity. For example, the sun bends space-time around it, which is why the Earth orbits it instead of floating off into space. In this way, everything in the universe, from planets and stars to light and energy, moves along paths defined by this fabric. But what if something disturbed this fabric so drastically that it tore apart? The structure of space-time, a delicate balance. The space-time continuum is extremely stable, but it's not invincible. Think of it as a trampoline. When you place a heavy object, like a bowling ball, representing a planet or star, onto the trampoline, it causes a dent in the fabric. Smaller objects like marbles, representing smaller celestial bodies or light, roll toward the bowling ball due to the dent. This is a metaphor for gravity. However, if you apply too much force, perhaps by tugging too hard at the edges of the trampoline, it could rip. In the universe, forces like gravity, black holes, and cosmic events such as supernova stretch and warp space-time. But even in the case of black holes, which warp space-time to extreme degrees, the fabric doesn't tear. So, for the space-time continuum to actually rip apart, we'd be dealing with unimaginable forces or exotic scenarios. What could cause a tear in space-time? Now that we understand the basics, let's explore what could cause such a catastrophic event. The idea of a tear in space-time remains largely theoretical, but physicists speculate that extreme conditions might make it possible. Here are some potential causes: singularities and black holes. A singularity is a point in space where gravity becomes infinite, and it's found at the core of black holes. Theoretically, if two black holes collided, or if a singularity became unstable, it could rip through space-time. While black holes bend space-time to an incredible extent, physicists believe the fabric remains intact, although it's stretched beyond recognition. Wormholes. A wormhole is a theoretical passage through space-time that connects two distant points in the universe. Imagine folding a piece of paper so that two opposite sides touch. A wormhole would be like poking a hole through the paper to connect the points. If such a wormhole became unstable or collapsed, it could tear through the fabric of space-time. Exotic matter. Some physicists theorize that exotic matter, a form of matter that behaves differently from anything we know, could also cause a tear in space-time. Exotic matter might possess negative energy, which could destabilize space-time and potentially rip it apart. The Big Bang. The creation of the universe itself involved a massive expansion of space-time. While the space-time continuum has been relatively stable since the Big Bang, a future cosmic event of a similar scale, like the collapse of the universe, called the Big Crunch, or its accelerated expansion, the Big Rip, could potentially cause a tear. What would happen if space-time tore? So what would actually happen if this cosmic fabric were torn? The consequences of such an event are purely speculative, but let's break down a few possibilities. Complete disruption of reality. The space-time continuum isn't just a physical structure. It also governs how time flows and how space is connected. If a tear occurred, the rules that dictate how objects move and how time progresses could break down entirely. We might experience time slowing down, speeding up, or stopping altogether. Gravity might cease to exist or become wildly unpredictable. Essentially, the laws of physics as we know them would no longer apply in the region where the tear occurs. Creation of a black hole. A tear in space-time might behave like a black hole, sucking in everything around it. Matter, light, and even time itself could get pulled into the tear. This black hole might continue to grow, potentially consuming nearby stars, planets, or even galaxies. Passage to another universe. Some physicists have speculated that a tear in the space-time continuum could open a doorway to another universe or dimension. If our universe is part of a multiverse, a collection of many universes, each with its own unique laws of physics, then a tear might allow travel between them. In this scenario, our universe could begin merging with another, leading to unpredictable and chaotic outcomes. End of the universe. One of the most extreme outcomes would be the complete unraveling of the space-time fabric, which could cause the universe itself to collapse. This could happen if the tear grew uncontrollably, with the entire universe's structure coming apart at the seams. Alternatively, the tear could trigger a chain reaction, leading to a new Big Bang and the birth of a completely different universe. The Big Rip hypothesis. There's a theory known as the Big Rip that proposes a future scenario where the universe continues to expand at an accelerating rate until it rips itself apart. In this theory, dark energy, a mysterious force driving the expansion of the universe, would eventually become so powerful that it would overcome the forces holding galaxies, stars, and even atoms together. As dark energy stretches the universe more and more, space-time itself would eventually tear, resulting in the destruction of everything. While this concept is still theoretical, it gives us a glimpse of what a torn space-time continuum might look like on a cosmic scale. If the Big Rip were to occur, it would be the ultimate end of the universe as we know it. Could we fix a tear in space-time? If a tear in space-time occurred, could it be fixed? Once again, we're venturing into the realm of speculation. Some physicists have proposed that highly advanced civilizations, far more advanced than humanity, might have the technology to repair such a tear. They might use exotic matter, gravitational waves, or even manipulate space-time itself to sew the fabric back together. However, for us, repairing a tear in space-time would be like trying to repair the structure of reality itself. It's a daunting task that seems far beyond the capabilities of any known technology or scientific theory. For now, the idea of repairing space-time remains firmly in the realm of science fiction. The bottom line. While a tear in the space-time continuum is purely hypothetical at this point, the concept forces us to think about the very nature of our universe and the delicate balance that holds it together. Space-time isn't just an abstract idea. It's the foundation upon which reality is built. If that foundation were to crack, the consequences could be catastrophic. Tears in the fabric of reality could lead to everything from time distortions to the formation of black holes, or even the end of the universe itself. While the thought of such an event might seem unsettling, it also serves as a reminder of the incredible complexity and wonder of the cosmos. For now, space-time remains intact, but the possibilities of what could happen if it tore keep our imaginations alive, inspiring scientific exploration and philosophical questions about the nature of existence.